Hi everyone, this is Sofyan from QCRI. I'm very happy to demo our tool QARTA, which is a machine learning based system for accurate map services. QARTA is a system that we created at QCRI and which we see as an alternative to commercial map services like Google Maps, Bing, Here, and Mapbox. So QARTA was actually tested in real life settings on more than 200,000 trips, and it's shown superiority in terms of accuracy for travel time estimation. We have recorded more than 4% improvement over Google Maps. QARTA is also very unique in that it's fleet aware. So we are able to learn different traffic models for different types of fleets, be it cars, buses, or motorcycles, and this allows QARTA actually to issue or to return different routes and different travel time estimations depending on the type of the vehicle that's making the request. Finally, QARTA is deployed as we speak in production in several companies in Qatar, including the national taxi company Karwa and the third largest food delivery company Rafiq, who issue more than 2 million requests per week. The general architecture of QARTA is shown here. This is like a multi-layer architecture, which revolves around an accurate map that we created. So this map has very accurate topology, but it also has edge weights for individual road segments. Now, for this to be possible, we have a first layer in QARTA, which is a data layer. This one is responsible for collecting data from different sources, and it's also responsible for indexing and cleaning, different spatial-temporal types of data like trajectories, trips, POIs, and so on and so forth. The second layer is the meat of QARTA. This is called the map-making layer. This layer actually is responsible for using the spatial-temporal data collected in order to improve the map and improve its topology by creating new missing edges, new roads that are created, or by removing some roads that have been closed for whatever reason. This layer is also responsible for learning the individual weight of individual road segments depending on the time of the day and day of the week, which helps us actually have a better understanding of the traffic. Finally, we have a layer called query calibration layer. This one is very unique to QARTA, and this layer actually encompasses a couple of machine learning components which are responsible for adapting the results to the real-time context of the user who issues the query. QARTA has multiple panels. So the first welcome dashboard looks like what we see here. Basically, this dashboard allows us to visualize at a glance the different vehicles and the motorcycles that contribute data to QARTA. These vehicles send data that we consume in QARTA, and this data includes the lat long of the vehicle, the speed of the vehicle, the angle, and the timestamp. And we could also know what is the status of different vehicles. So these vehicles could be free, like available, or hired, serving a client or customer, or could be dispatched, so going to the location from which they could pick up the customer or pick up the delivery, depending on the company. This welcome dashboard shows also the some statistics about the APIs or the requests that are sent to our backend. So we have at a glance the hourly number of requests that QARTA actually is resolving. But we also have a very specific map panel in which the user can, for instance, pick a day of a week and then an hour within that day and visualize the actual traffic patterns of individual road segments for that particular hour of the week. This is important actually for the analysis that allows us to understand the congestion behavior at different locations of the city. A user can also click on an individual road segments, like in here, to show this pop-up where we have report different metadata, some of which actually are computed using the machine learning components in QARTA. The third panel is the query panel. This one allows user to interact with QARTA. So first, the user can pick the type of query they want to issue. Let's say they do routing, but we also support KNN and range queries. Then you can pick the map that you'd like to use. You can use QARTA map, which is super accurate and has the edge weights, or use like a base map like OpenStreetMap. And then you can also decide on whether you want to do calibration or no calibration to the output. And because we are doing routing here, we have to specify the source, destination, and then the departure time, because we have different traffic models for different hours of the week. The results actually include the distance of the route. They include the ETA, which is 20 minutes here, but we also show other ETAs like the free flow ETA or all-time ETA, which doesn't account for traffic, and Google Maps ETA for comparison reason. We also have in the result list of instructions for the direction. The final panel is the admin panel. This one is used exclusively by us who are running the backend part of QARTA. And this one actually allows us to decide on how frequently we want to update our different machine learning models. So for instance, if we take the QARTA calibration module, we run it every day. So this runs every day at midnight. And then for each run, we use the data from the last 7 days. So we have like sliding window of 7 days that we use in the training. And we have some parameters for the algorithm itself, like the temporal partitioning and spatial partitioning, which consume like some shapefiles. Thank you so much.